to discuss the second assignment. So in the theory class, we are discussing lots of system calls. So, so I guess we have already gone through fork to create a process, and then exec to execute a process, wait, right? So we are going through these. So in the second assignment, we have planned something which will ask you to use these system calls to do something useful. And that useful thing is that you have to design a Linux type shell. Okay, so the shell on which you give commands, that's also a program, right? So it's a program which takes your commands, it displays the prompt, takes your command, and then gets it executed. So you will have to design that kind of a shell. Of course, we would not go for a full-fledged shell of Linux, which has lots of functionalities. We shall go for a shell which will have some basic and a few advanced functionalities. Okay. So yeah, so let's just walk through the assignment a bit. So yeah, so you have to implement a shell which runs on top of the Linux kernel. So essentially, it talks with the Linux kernel through these system calls. The shell will accept one user command at a time and execute the same. So what are the features that we want in this shell? As I said, we want to go for a full-fledged shell. So these are the features that we want you to implement. One is runs an external command, right? So essentially, say for example, a program.c or cc or ls. So as you understand, the shell should not run. So the program that is running as your shell should not run this directly. Rather, it should fork a child and then invoke exec in that child, some variation of exec or some similar system call, and then get this program executed or this command executed, right? So the shell should continue to operate as is. As we understand in a normal shell, we give a command, and after that command is executed, the shell prompt comes back. So the same thing should happen. So one way to do this is that you have this parent process, which is running the program that you have written, the shell program, that will fork a child, and the child will use exec, some variety of exec, to execute the command which has been issued. Whereas the parent goes on waiting for the next command. And after the after the execution of the current command ends, again the shell prompt is shown and it waits for the next command. Okay. So that's running an external command. Now, some variations of that we would like you to implement. One is redirecting standard input. So I think, most of you may be familiar that you can make one program take input not from the terminal, that means the standard input, but from a file. And to do that, you use this like less than symbol. Essentially, if you run say /a.out and less than infile.txt, then a.out will take inputs as if not from the keyboard, but from infile.txt. So whatever you wanted to give as inputs, you could have given it as from input or from the keyboard. Rather, if you write the same thing in infile.txt, then a.out can also read from there. So this we want you to implement in your shell. So we have given names of some system calls which you would find useful, like dupe. Dupe stands for duplicate. So dupe and dupe2. So dupe and dupe2 are two system calls which will help you to duplicate a file descriptor. Right? So look up these system calls using man pages or the internet or some book, and then you can use these to implement these features in your shell. Okay, so civil, just like you can redirect input, you can also redirect output. So that means, let's say your C program, when it will give a printf, it normally prints to std out, which is typically the terminal. But instead of, you can redirect that output to a file, let's say outfile.txt, so that whatever would have been printed on the screen now is written into outfile.txt. Okay. So, okay, fine. So, and of course, you can combine the two. You can combine input and output redirection. Okay. Now, okay, till now, any questions?
So this a.out will be run in the default shell, right? I mean default terminal which we have.
What is a default terminal you mean? I mean, you are running up, so you have written a shell program which is executing. So this command that you see, say /a.out redirected to outfile.txt, this will be input to your program, your shell. Okay, this is an input to your shell. So your shell should arrange these things that a.out is run, possibly as a child process, and the output goes to outfile.txt. Does this make things clear, or if not, then ask?
Yes, sir.
Okay.
Yes, sir.
Okay, I have one question here, you all. So we are talking about, say, okay, output redirection, this one, right? So how is this different from, let's say, your C program writing to a file? So we know that we can open a file from a C program, fopen, and then we can write to that file. How is this different from your C program opening a file and writing to it? Or is it different at all?
This redirection opens, opens the file only after its complete execution. I think.
Redirection opens the file after it is okay. I'm not sure of the answer. So can you elaborate? First of
Like
all,
in C program.
okay, who is answering? Your name?
I'm needed, sir.
Neeraj. Okay, yeah, Neeraj. So can you elaborate a bit?
So if consider /a.out prints ABCD A to Z in different lines.
Sorry.
Consider /a.out.
Hello.
There's a technical problem from my end, so I can't speak.
Okay, Neeraj, can you hear me now?
Yes, sir. So I think there's a
Yeah.
technical problem. I'll tell later then.
Okay. I mean, so are you answering the question? As in, I did. Okay, so you did give some answer. I did not fully understand it.
No, sir. There's a technical problem, I think, sir. That's why.
Okay, fine. Okay, so anyone else? Like, how is this like redirecting to a file, redirecting output to a file? How is this at all different from your C program opening a file and then writing to it? By the way, this question I am not asking in the light of this assignment. Even in the normal shell, the standard Unix shell or Linux shell that you have, you can give this command, right? How is that different from your C program opening a file and writing to it? Anyone?
So did you get the question?
Okay, I hope we are audible.
Yes, sir.
Okay.
Sir?
Yeah, so any answers? Yes.
Sir, I think the input.
Whoever was talking are muted now.
I think from the next time you should be the.
Actually, someone is removing everyone when he or she speaks. That's very bad. I don't know why someone is doing.
Really?
Yes,
Someone
yes.
is removing others.
Yes.
Yes, sir, it is happening.
That's a bit strange. I mean, we did not expect this to happen in a third year core class.
Wow. Okay.
Hmm.
So if someone really wants to remove others, I would actually believe that that is your prerogative now. Your third years, right? Okay, so Vamsi, you're talking, right? Hello? Hello?
Yeah, at least Mainak, I can hear you.
Yeah, I don't know whether others can hear me. Can you
Yes,
guys hear
sir.
me?
Yes, sir. We can
Yes,
hear
sir.
you.
Yes, sir.
Neeraj, Vamsi, can you guys hear me?
Yes, sir.
Yeah, so whoever doesn't want to be here, please don't join. It's fine. I mean, we are anyways recording.
Yeah, and we are not taking attendance
But
and all. So
why are you disturbing
yeah, why are
others?
you here if you are not interested? Fine, don't be.
Why
Or
are
maybe
you
life has
disturbing
become too
others?
boring. This is the only entertainment left.
I mean, this is perverse actually.
Hey,
It's extremely
Spring Fest
perverse.
is coming. Why? I mean, this entertainment. There should be other modes of entertainment, I guess, in life. Hmm.
Okay, we'll actually start again. So Neeraj, are you there?
Yes, sir.
Please finish whatever you are talking. And
Oh,
if you are removed again, we'll just close this down. Okay?
Yeah, we'll just give the
And
assignment. I mean,
yeah, we'll just give the
yeah,
assignment.
I don't think. I mean, you intelligent people, you can figure it out for yourself.
And you can also figure out that who is doing it. And that's your prerogative to deal. Okay? So Neeraj, please continue where you started, because then now I understand that someone was removing you, which will just not stand. Neeraj,
Hello,
are you
sir.
there? Yes,
Yes,
please
sir.
continue.
I
And
just
then
wanted
Vamsi, you are going to talk.
I just wanted to tell, after the complete execution of ADODOC, whatever it is expected to show in standard output, once the only one time outfile.txt open, and then all these things get appended into it. That's it. That's the difference. Like, I just wanted to tell that.
Okay, thank you. Anyone else wants to give a different answer or add to this?
So,
Yes,
like,
Vamsi, you are telling something. Kamchiti, Vamsi, are you there?
Hello.
sir,
Yes, you are telling something, right?
sir, I had a different answer. Like, if
Mhm.
the output is produced to standard out and then the output is copied to a file.
Mhm.
Okay. Okay. See, let me give you some kind of pointers. First of all, think that who is opening the file at all? Outfile.txt. Who is opening the file? Is the C program opening the file?
Like it is echoed into that output file.txt.
Okay, no, the answer is no. I mean, it is not like that. See, if you redirect output, essentially, I mean, the C program, say, which is running, which is out, that does not even know that the output is going to a file. It just thinks it is outputting to standard output. But then somehow standard output has been connected to outfile.txt. And who will do this connection? The shell. So the program, so in the default shell, default Linux, the default Linux shell does it. In this assignment, your program should do it. Right? See, out is not written by you. Out is just any program. ls. So ls just prints to standard output. You cannot ask ls to open a file and then print there. Because ls code is not yours, right? So this program which is running a.out ls, they just think that they are writing to standard output. But then somewhere someone has to connect that standard output to these files. Who is that someone? The shell. And in this assignment, your program will do it. So basically, you'll have to understand how to connect standard output or standard input to a file. So your shell should open the file and then do this connection. So that's the difference, right? The program does not even know, I mean, that a.out or ls, they don't even know that they're writing to a file. Okay. Okay. Okay, I'm assuming I'm audible and proceeding. So,
Yep.
Okay, so B is about redirecting standard input, part B. Part C is about redirecting standard output. But Mainak, if you want to add anything, feel free to add, right?
No, I think this is pretty okay. I mean, the discussion is cool. So yeah.
Okay. So part D is do both together, like combination of input and output redirection, right? So basically you have to redirect both standard input and standard output. Now, part E is a bit different. So again, in the default shell, you can ask a command to be run in the background. I think in the first lab class, Mainak showed you an example that using this ampersand symbol at the end, you can make a program run in the background so that the shell won't wait for it. Right. So understand the difference. When we just normally say we write /a.out, then the shell waits for this a.out program to end. But here, if we make a.out run in the background, the shell won't wait for it. You will immediately get back the shell prompt. Right? So that's something that we want you to implement. So how we have to understand how to send a process to a background, how to send a command, how to make a command execute in the background. And of course, all the things can be done together, like redirection and background, everything can be done together. Now, moving on to part F. This is something which possibly has not been covered in theory class yet, but will be soon. So, processes can talk to each other. So processes can communicate to each other. So for example, I think you are already doing network lab where you have two processes running on two different machines and they are communicating with each other. In the OS lab, we will have processes running on the same machine communicating with each other. So the kernel provides many ways for processes to talk or communicate with each other. These are called inter-process communication or IPC mechanisms. IPC, inter-process communication. So we will cover the part in the theory very soon. But part F is that. So essentially, we want the output of one command to go as input to another command. Okay. So see the commands first. This is the pipe symbol. Okay, the pipe symbol is used to make this connection. So here we are telling that ls command will run and the output will not be printed on the screen. Rather, it will be directly given to the more command. What does more command do? What does more command do?
Sir, a text editor kind of thing.
So more is actually like if you know that the output of a command would be huge, you cannot fit it in one screen. We give this more kind of command which will show you it in parts. So it will show one part and then wait for you to press a key, then it will show the next part and so on. So suppose you have this directory with 5,000 files. If you do an ls, all the 5,000 names will just scroll by. You won't be able to see anything. So ls pipe more means that the ls command's output will be shown to you phase wise. So the first 5% is shown to you. Then when you press a key, next 5% is shown to you. Then next you press another key, next 5% is shown to you, like that. Okay. Then often we want to sort a file. So we cat will show a file. It will append the file. It will simply print the file to the standard output. And then we are redirecting, or sorry, we are not redirecting. We are sending the output of cat directly to sort. So that sort will sort and then give the output. Or sort will even send to more, and more will give us the output. So this pipe feature can be used to connect the output of one command to the input of another command. So this is also a sort of redirection. The previous parts were redirecting to a file. Now you are redirecting the standard output of ls. In the first example, you are redirecting standard output of ls to the standard input of more. So for doing this, there is this pipe system call. Okay. So again, I mean, these are not too difficult to use. Check their man page or check some tutorials. There are also some hints given here in this assignment itself. So you have to understand how to use this system calls and run them. Okay, part G is interrupting commands running on your shell. So I think all of us do this habitually, that suppose we are writing a C program and by mistake it has entered an infinite loop. So what do? Control C. So the program which is running stops executing. But here there is something to note very carefully. Pressing Control C should stop the program which is running as a part of the command. It should not stop the shell. Right? So you will also have to write your shell in such a way that pressing Control C does not stop your shell. It stops the command which is running. Okay. So for this, you will have to use something called signal handling, which again we have not covered in the class yet, but we will soon. It's essentially signal is a mechanism by which kernel can inform a process something. Say, I mean, a process is running and so the user has chosen to stop the process. Okay, so then the kernel will send a signal to the process saying, but so signals have these codes and all. So the kernel will send a particular signal with a particular code to the process, which would signify that the process should stop. So processes actually listen for signals, and depending on what signal has come, the process can do something. So yeah. So this kind of a thing we want you to implement in your shell. Okay. Is this terminal visible?
You might want to zoom in a bit. Command plus plus.
Better?
Yeah.
Yes.
Okay. Let's see what some processes are running. Okay, okay, so I have a, wait. Okay, let me open a browser. Yeah. Let's see. Let's see once. Okay, so I've opened the Safari browser. Fine. Now, if I do a PS, it will give a lot of things. How can I find Safari? Will it the name of a Safari? Yeah, okay. Oh no.
grep minus I.
No, it still shows this grep only. So it's not running under Safari, okay? PS will give a huge list. Okay.
Just PS ox. I mean, without any minus.
So okay. 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 So at least I can see a so okay, Safari. I don't know what to search for, but at least for Chrome, you
So,
see.
so for this, they should use pxox grep minus I Safari works for me. Perhaps it is not running for your machine somewhere.
Maybe
But
I don't know. I started up Safari, but it's not showing somehow. Okay, fine. Okay, so at least I have this Chrome running. So this is the see when I do a PS, the PS shows the list of processes. PS shows the list of processes and see first of all, I have myself used the pipe command here. So PS AUX if I give, it will give a list of all the processes. I do not want to see the list of all the processes. I want to specifically find out processes which, I mean the Chrome, processes related to Chrome. So I'm taking advantage of the fact that somewhere in this name, Chrome word will be there. So I'm saying PS AUX pipe, then grep Chrome. Grep is a regular expression matching tool. So I'm looking for those lines from the output of PS AUX, which contains the word Chrome, or which contains the string Chrome. So I have got these as output. So it seems that 6116 and 618, these are the process IDs of the processes which are running Chrome. So now suppose I want to send a signal to this Chrome process. Okay. So there are many ways of sending signals. You can programmatically send a signal. That means you can include something in your program, C program, which will send a signal. There is a system call called signal, which we will cover in the theory after a few classes. But for now, just from here, I shall use, there is a command called kill. Okay. So there is this command called kill. As you see the man page, terminate or signal a process. Okay. So the kill utility sends a signal to the process as specified by the PID operands. Okay. So, and you can choose what signal to send. You can choose what signal to send. So let's see. So I choose to send signal, a particular signal, which is I can give the, let's see man kill what it says. So there are different types of signals. Yeah, see, if you see, these are the more commonly used signals like 1, 2, 3, see 9. 9 is a kill signal, a sig kill. Okay. So if you if a process is sending a kill signal, then it should stop. Okay. So let's try to do that. I want to send a kill signal written as -9, kill -9 to one of these processes. Let's see. Okay, so I have this Chrome running in the background, right? I have this Chrome running. So kill -9, let's try 6116. And 618. Ah, strange. I don't know. It's Mac. Does Mac handle things differently? I don't know. Anyway, this works in a Linux system. Mainak, any idea?
Not quite.
Yeah.
This thing should work.
Yeah, exactly. And this works every time in a Linux system. So
it
yeah,
will work also. It will work here also. It should. But 9585.
9585. Okay, 9585. Okay. Yeah, but the Chrome is not sure. That's a bit strange.
Okay. So
Anyway, sorry about that. But yeah, I mean, this happens in a Linux system.
No,
Anyway.
it is 9585 is a helper app. It is on the main Chrome app. But
yeah, but okay, so so does the main Chrome app run as something which does not contain the word Chrome? I don't know. Anyway, okay, sorry about this. Huh?
Yeah.
Why are the IDs getting changed? The process ID. It is different from the previous picture PSOC. Like, until the program gets some.
Yeah, I mean, it seems Mac handles things differently. So I mean in the previous time when I sent a -9 signal to kill, sorry, 9 signal to 6116 through kill, I expected the Chrome to stop. But now it is showing with a different process ID. So I don't know how Mac is handling.
What happens is, okay, let's actually ask the class. So what Saptarshi is trying to do is to send a kill signal using the process ID, the PID that we learned about in class. PID is given by PSOX. However, yeah, the question is that why this is not working, or is it really not working? A killing will be cascading or something, like it will kill all the child processes. That's a good point. Yes, but still, Saptarshi is not really seeing Chrome getting killed. No. Why? Any idea?
So can you repeat the question, please?
Yeah. So when during demo, we are sending the kill signal with a -9 flag to a process ID, in this case to the Google Chrome. However,
and see here, sorry,
Google Chrome is still.
Sorry. So understand what is the significance of this 9. I'm showing you the man page of kill. 9 is a non-catchable, non-ignorable kill. So if a process is sent the 9 signal or kill signal, essentially called kill, then it should terminate. Okay. So now the question is, but here it's not actually happening. So that is the question, why? Yeah, Moinako.
Yeah, I just want to actually know that, is it that the kill is not working in Mac? That is one possibility. Anything else?
Maybe it's restarting on its own because it's connected to something else. So maybe that process is a child of something, and
Awesome.
it's in.
Yes.
It's actually maybe the parent process is maybe checking for its child process again and again. So if it's not working, so it will remake the child and then make it do whatever it was supposed to.
Exactly. So all these Chrome processes that we are seeing here, that is spawned by some one Chrome process, that is basically going to recreate the processes as much as we kill. We need to kill the parent process, but this child process will be killed. So when he is sending this 9585, and then if he giving again PS grep Chrome, then he will say 9585 is not anymore the Chrome process. The PID changed, meaning it's a new process.
Yeah, now we have new IDs. 9599. Okay, and 9582 is still remaining. Yeah. But now we don't have 9585. Now we have 9599.
9582 is your Microsoft Teams. You might want to try to kill it, but they will crash the whole thing.
Yeah, so I'm not trying to. But that Teams also is using that. Yeah, so sure.
So the point remains, when you try to, I think this is this demo, of course, it didn't really go as planned because the Chrome is not closed, but it actually identify an important part for your assignment. When you try to kill a process, you need to give the correct process ID. If not, it will send it to a different process and that will be killed.
So if any of you are on a Linux system, you can actually try to do that. Choose a process and try to find its ID by looking at the PS output, and then send a kill signal to it using kill -9. So kill -9, then the process ID. Then you should see that process being killed if you have identified the correct process ID. Okay. Fine. So this is, so in part G, that is what we want you to implement. So if someone is presses a command is running, like a C program which has gone into an infinite loop, and someone presses Control C, the user presses Control C, then your shell should arrange so that a kill signal is sent to that process which is running the error.out. Okay. Similarly, you have Control Z to move a process to the background. Okay. But again, remember that when this Control C is pressed, your shell should not stop. The shell program that is running, that should not stop itself. Okay. So these are the parts of the assignment. Now, when you see the PDF, you will see that we have given some implementation help. So again, as I said, this assignment statement contains some names of some system calls, which you need to understand. And this implementation help talks a bit about the standard input and standard output processes. Sorry, not processes, the standard input and standard output file streams. And then you will need to read up system calls like dupe, then pipe, these kind of things, which will help you to redirect input and output. Right? So essentially, dupe you can use to make a copy of a file descriptor. So essentially, std in, std out at the process level, these are file descriptors. You need to use dupe and other system calls to make a copy of them and then connect them to the correct redirected file stream. Okay. And yeah, and again, this is the thing I told, that if you want a process, normally when a command is running, shell waits for it. The shell prompt does not come back until and unless that execution of that command is over. But suppose we do not want to, we want to run a command in the background. So shell should not wait for it. Rather, the shell prompt should come back immediately. This can be managed by whether your parent process is calling wait or not. So if the parent process is the shell that you are writing, if that does not want to wait for a child, that means the child will run in the background, then your parent process should not call wait. So then the child will run independently and the shell prompt will come back again because the parent is running independently. And again, you have this pipe system call, which will help you to create these pipes. Okay, and finally, yeah, the submission guideline. We have okay. One important thing, this assignment will be given in two parts. So this is part 1. There will be another part which will be declared next week. Okay. And so finally, your program should be a shell which, say, the person who is the TA who is evaluating your program should be able to run that shell and give such commands and see and get expected output. Okay. We have also given a sort of marking scheme here of the 7 parts. So yeah, you'll get an idea of how many marks are there in which part. So now that is the description of the assignment. Now, if you have any questions, then please go ahead. Okay, is this
Hello.
PDF already given to them?
Yes, it's in the CSC module.
Yeah, fine. So I'm stopping sharing the screen, then we can take questions.
Sir, can you hear?
Yeah, we can hear you.
Yeah, so when we open two different instances of an application, they should run in different processes, right?
Yeah.
So what I tried is I opened two instances of my terminal emulator Alacrity, and it showed two different processes. But when I opened two different windows of gedit, it was the same process. Why is that so?
Okay, so I would guess that apart from processes, there is something called threads, which we will cover in a bit of time.
Okay.
So some programs may choose to run different instances, not as different processes, but as different threads.
Okay, and is there any way to see the threads?
See the threads means?
If we run psox, then we can see the different processes according to the IDs, right?
Programmatically, yes, but given a Unix command, a Linux command to see the threads, I don't think so.
Top or htop?
Top.
Top or htop, yeah.
Top or htop.
I guess htop will work. Okay, thank you.
So how many Chrome crash are running? Is there there's multiple MD worker, Chrome crash, Chrome.able, Microsoft Teams. So yeah, top or htop should help you.
Okay, let me stop sharing the screen. And if you have any questions, go ahead. Yeah. So any other questions?
Any other questions?
Sir, I think previously you have searched for Chrome, which is starting with small c, right? I think we can find it if it is capital C. Like when you type top, it is showing capital C Chrome.
Pardon?
Oh, sorry. Previously, when you tried to see the ID of the Google Chrome, it didn't kill it. I think Saptarshi sir searched for Chrome which with small c at the starting. And
Yeah,
the
but he
Google
also
Chrome.
minus I. I actually grep minus I will be case insensitive to search.
Okay.
Okay, anything else about the assignment?
Stopping the sharing then. Oh.
Sorry?
No. It's fine. I was about to stop the recording, but I realized that I cannot. Someone else can. I can. So I'm stopping the recording.